Hello students, today we are going to see some of the numericals on the topic friction. You can turn to page number 281 in the book, and just after the friction theory portion the numerical starts. So we'll do some of the example questions today. So the question is question number 12. Let's read the question. A block of mass 15 kg is placed on a long trolley. So you can draw this diagram here. So on a long trolley, there's a block is kept here. The coefficient of friction between the block and the trolley is 0.18. So you can write here mass is equal to 15 kg and coefficient of friction is there. What is coefficient of friction? What symbol you will give here? It is called mu. Mu is equal to 0.18. So this is coefficient of static friction it could be. So the trolley accelerates from rest with acceleration is equal to, so what is the acceleration? It is 0.5 meter per second square. For 20 seconds, time is equal to 20 seconds. Alright, and then moves with a uniform velocity. So if you look at the situation here, so the trolley is accelerating like this. So you will find this is the trolley with the block on the top of it, and you have the wheels of the trolley here, and the trolley moves. Whenever it accelerates, what will happen here is you will find a backward push of the force will be acting on this one. Alright, so the acceleration forward will give a backward push on this one. Now first of all, we need to find out what is the kind of an force which is being applied here. What is the force which is being applied here? And then the mass is already 15 kg. 15 kg is the force. Alright. So the backward force, the force on the block due to acceleration. So what is that? Capital F is equal to m into a. So that's equal to 15 into a. 15 into 0.5, 7.5 newtons. So 7.5 newtons acts here. When it is acting here, where will the frictional force will be acting? When this body is about to move in this direction with a force of 7.5, the frictional force will be acting in this direction. And we call it as Fs, the static friction force. We'll see whether it is a static friction or kinetic friction. So you get this Fs. Now the body will be moving, having the mg down here, and it will have the normal reaction up there. So the second part is frictional force. You need to find out frictional force. So what is the frictional force? Fs is equal to mu into r, mu into m into g. So mu is already given here as 0.18 and mass is 15, and this is, you can take it as 10 maybe, or you can take it as 9.8 also. So once you try to do this one, I don't know what they have given, and they given 9.8. okay, once you do this one, so you will get a force of frictional force of 26.5 newtons. You will get frictional force. Now in which direction the body will move now? This is 26.5 and this is only 7.5. Which direction the body will move? You might say, oh, the body will start moving in this direction. No, it is not possible. Frictional force, even though it is bigger, this is the maximum frictional force. Whenever a force of external force of 7.5 newtons acts on this frictional force also will adjust according to that particular force. So frictional force, how much it will be then? It will be only 7.5. Will it not be 26.5? Yes, it will be 26.5. If this one goes to 26.5, it will become 26.5. Frictional force, the self-adjusting force. So, what is the question it is asked? The trolley accelerates and then moves in a velocity. Discuss the motion of the block as viewed by the stationary observer. As viewed by the stationary observer, this block will be going along with the trolley, static in the trolley, with the acceleration here like this. And observer moving with the trolley, a person is standing here and seeing the block, the block will be at rest. Okay, block will be at rest when trolley is moving. Okay, so you have to write there the frictional force finally will be equal to just 7.5 newtons, because to adjust this one. Okay, we'll go to the next question now. Okay, we will do question number 11. Two bodies A and B respectively of masses 5 kg and 10 kg in contact with each other rest on a table against a rigid wall. The diagram is already given here. A block is 5 and this is 10, and both of them are resting on the rigid wall. The coefficient of friction between the bodies and the table is 0.5. That's the frictional force in between under this one. It is 0.5. This is mu. Now write down here. M1 is equal to 5 kg. You have to draw the diagram also. M2 is equal to 10 kg. And mu is equal to 0.15. And the force, external force given is 200 newtons. So on this block, so what you have experiencing is so this is A block, this is B block, this is 5 kg, this is 10 kg. So this is 200 newtons. Now what happens is, when this 200 newtons is applied, now you need to find out what is the reaction of the partition. This one will be giving a force to this one. By this one, this will also be giving a reverse back force. The partition also will give a reverse back force. How much this force will be getting? Most of them will give an answer as this is giving 200 newtons, so this also will give 200 newtons. Remember, that will not be the case here because you are given a frictional force. Don't think this 200 newtons will be always 200 newtons when it reaches here. It cannot be, because there is a frictional opposition will immediately start whenever you give the force, even though the body is not moving. You need to subtract the frictional force. So it is not 200 newtons. It is not going to be the opposing force. It will be definitely the capital F minus small f. The frictional force should be there. Then only that will be the final force which will be going. Right? So you can write down force acting on the partition is equal to F dash is equal to capital F minus the frictional force. So this is 200. What is frictional force? Mu into R. So it is mu into M into G. So you can say M1 plus M2 times of G. So it is 200 minus 0.15. And what is M1 plus M2? It is 5 plus 10 into G is 9.8. So it is 200 minus 0.15 into 15 into 9.8. So what is the answer you get here is 200 minus. So you get a subtracted value as 22 newtons. It is going to be equal to 178 newtons will be the force. F dash. What will be the reaction? Reaction of partition is going to be minus 178 newtons will be the F dash. The reaction is going to be. So that's the first question. The first question is done. The action and reaction of A and B we have done. What would happen if the partition is removed? You remove this one, what will happen? This started moving now. Once it is moving, it becomes kinetic friction, and this one is going to already oppose this one with this frictional force. The frictional force is going to be 22 newtons. It will be opposing this one. Now we need to find out, does the answer change when the bodies are in motion? Ignore what's going to happen. Now when the body started moving, what will be the force? How much will be the force in which it will be moving? So we need to find out that. Okay. So we will go to the next part of it. Now the one more thing is, the action reaction forces on A and B also. What is the action this is giving and what is the reaction this is giving also, it is asked. Action and reaction. The action coming from A to B and B to A. How much will be? It will be 2000? 200 only? No, it will not be 200. Only this body's one you need to subtract. Okay. Now look at this one. So you will find this particular stuff is going to be. Now look at this question itself. So the force, the limiting force, the friction of the body A alone. So only the body A, how much force this will be having. So you have the force on A is going to be equal to M1 into G times of mu. So mu is 0.15 into 5 grams is the M1 into 9.8, that will be 7.5 FA. So FA will be the 7.5 and this also will give 7.5 back newtons. Alright. So what will be the value then? How much this will be? This is 7.5 is the frictional force. How much the 200 if you subtract? So F double dash, or you can say FA dash. For FA dash is 200 newtons minus 7.5 newtons. It's going to be 192.5 newtons will be the force of the here to here. Force from A to B is how much? 192.5 newtons. Right? Then it is actually it is 3.35. It is, if you look at this question, it is 192.65. It is coming 65, right? 65. Now the next one is partition is now removed. You remove this partition and then the body starts just moving. What is the acceleration here? When the partition is removed, when the partition is removed, so what is the value here? It is the final force, the net force. What is the net force? 200 minus the entire of this one, okay, upon M1 plus M2. What is the net force? 178 upon 15. So the acceleration will be 11.9 meter per second square. That is the acceleration. So if that is the acceleration, that's what the thing will be. When the partition is removed, what acceleration you will get? You will get this acceleration. So with that, this question gets over. Okay, and you can also find out in what is the force exerted between A and B, when it is already moving like this. This is 5 kg and this is 10 kg and it is already going with a speed of 11.9 meter per second square. That is an acceleration, and this is 200 was there and this is opposing us 22 newtons because of the frictional force. So subtracted is 178. So it is moving. So what is A to B? From A to B, what is the force? And B to A, what is the force? Now we can calculate what is the force here and what is the force there. We can easily calculate also. So that's also calculation is given here. Right? So what is the force of this one of A? FA is going to be equal to M1 into A. It is 5 into 11.9 meter per second square. So 5 into 11.9 is, it is 59.5 newtons. That is a force which this is having, right? Now if that is a force which is having, now we need to subtract this force with 192.5. Now this is the total force in which it is moving. So what will be the force F this will give here? That is FA is going to be equal to capital F minus FA, because this is the F force. So 192.65 minus 59.5, that's going to be equal to 135 133.15 newtons will be the force from here to here. Again I am explaining how this one came. 133.15, how this one came. Now look at this one. This body is having a force of this much because of the acceleration. Alright. Now already 192.65 is the force which has been given in the static position. Okay. And because of this one, when this is already moving individually with the force of this one, the force given from here and the force given back here will be 133.15, which has to be subtracted from the bigger force which is there. So that is the end of the next question. Alright, we'll go to the next question, question number 10. A man of mass 65 kg is standing stationary with respect to the horizontal conveyor belt, which is moving with an acceleration of 1 meter per second square. This is going in a 1 meter per second square acceleration. That itself is quite a bit. As soon as if somebody is going in a speed, will be the backward force will be hitting here. He will be having a backward force. But if it is a backward force is like this, his frictional force, we can calculate how much is the frictional force of this man and the shoes. Find the net force on the man, because there is a backward force and the net force on the man we can calculate. So it is asked, find the frictional force. Now first of all, write down the basic quantities. Mass of man is equal to 65 newtons, and then acceleration is going to be equal to how much? 1 meter per second square. So the force acting on the man, how much it is? M into A, 65 into 1, it is equal to 65 newtons. After 65 newtons, this is the force. This force will be acting behind. Next line is frictional force is equal to small f is equal to mu into r, mu into m into g. It is going to be, what is the mu value? If the coefficient of static friction between the shoes and the belt is 0.2 is given there. 0.2 into 65 into 9.8. So what is the frictional force? The frictional force, after you find out, it is going to be 127.4 newtons. Alright. So this is the frictional force. He has a very good frictional force. Now when this guy is standing here, frictional force is so much, 127.4, and the backward force is only 64. Now tell me, will the man fall down or keep standing? According to me, since frictional force is so high, this guy will keep standing. He will not fall down. Alright. So now the thing is, if the man has to fall, how much should be the maximum acceleration? 1 meter per second square is a very tiny acceleration. Only 65 newtons is creating. How much acceleration should be so that it can go up to the frictional force of 127.4 newtons. So you have another calculation. Acceleration, maximum acceleration is going to be equal to the frictional force, right, upon mass. So 127.4 upon 65 kg. 65 is the kg of the man. So now you do the calculation here, you will get almost 1.96 something you will get meter per second square. 1.96 meter per second square. Okay. So this much of acceleration it can be there, and that point of one time only this man will start falling down. Okay. It is asked, up to what acceleration of the belt can the man continue to remain stationary relative to the belt? Yes, up to this much he will continue to stand. What did I do now? How did I arrive at this answer? Because I have said maximum friction is this much. Let that be the maximum external force. Let that be a maximum external force. If that be the maximum external force, then frictional force should be equal to the maximum external force. So the capital F is going to be equal to small f maximum. So we have put this value here and then got this answer. Okay, we'll go to the next question now. We go to the previous page number 279, question number 9. So a block A of mass m1 equal to 20 kg rests on a horizontal table. A 20 kg mass is sitting here. So this is 20 kg. A light string connecting to it passes through over the frictionless pulley, and a block B is hanging over. This is 3 kg. Right? And is fastened. The coefficient of kinetic friction is this, between this one is 0.04. The block A is sliding on the table. Calculate the acceleration of each block and the tension of the string. We know this one very well. We know how to do this one, but we know it without friction. Now a little added component is there called friction is there. So you need to be a little careful about how to do this one. So first of all, draw the diagram. The same diagram, please draw it, and we'll also try to take the components accordingly. Right? So this is the scenario now. It is 20 kg which is there. This will have m1 into g, and this will have the normal reaction as r1. When this body is at rest, there is a constant force of tension which is there because of this one, because of this body which is going m2 into g downwards. So there will be tension. This will immediately apply a frictional force. You will have a frictional force which is there. We need to find out the frictional force also. And then we need to find out the entire thing of how this body moves. Now considering acceleration is going to be downwards, so you can write down force acting on m1. What is the force acting on m1? How will you do this one? Last time and all, without friction, what you will do is tension is equal to, the tension is going to be equal to m1 into a, this entire body into a. That's what we do it. But right now it is just not tension is equal to m1 into a. The frictional force has to be subtracted. So you have tension is equal to m1 into a minus, what is minus? The frictional force. So m1 into a minus mu into m1 into g. So that is tension here. Equation number 1. Next line. Force acting on m2. Here. This one minus this one. This one already we know how to do this one. Because this is tension. Which direction it's going? m2g. Which will be greater? Tension will be greater or m2g will be greater? And there is no friction here. So m2g minus tension, because this will be bigger and this will be smaller, equal to m1 into a. So this is equation number 2. Now add both of them. Okay, you can add both of them and then see how it happens here. Alright, so we'll see how it is being done here. Right. One change which you need to make is here is, this is going in an acceleration A. When this is going in acceleration, now tell me which force is bigger. Here this equation needs little more relook. Which force is bigger? Tension is bigger or frictional force is bigger? Definitely tension is bigger. When tension is bigger, how this equation should have been written? Is it like this? Can we write like this? Take a look on it. We have written m1 into a is bigger minus friction is equal to tension. That is not the case. It will not come like that. Tension minus friction is equal to m1 into a, it will come. So it will become tension minus frictional force will be this one. So you can strike off this and rewrite a bit here again as force on m1, tension minus the frictional force is equal to m1 into a. So tension minus mu into m1 into g equal to m1 into a. This is equation number 1. Right. So now we'll move forward how to do this. So we got two equation number 1 and equation number 2. We need to find out the acceleration. So first of all, what we do is this equation we rewrite it as, right, tension, you keep it in one side, take all the things to the other side. So it is m2g minus m1 into a. This is equation. This equation you write here like this. How will you write? Tension should be in one side, other things to the other side. So m1 into a plus mu into m1 into g. Alright, because tension, this whole thing goes to the next side and it minus will become plus. Equate. Okay, equate both is 1. m2g minus m1a equal to m1a plus mu into m1g. This is here and this is here, that's all. Now we need to find out the acceleration. So how to find out the acceleration here? So this one can go that side and this one can come here. So m2g minus mu into m1g is equal to 2m1a. So what is acceleration then? m2g minus mu into m1g upon this whole thing equals 2m1. This is the acceleration now. Some mistake is there somewhere. Did not get the right answer here. Yes, this is the biggest mistake here. When this body is going down and this body is going down, m2g minus tension is equal to m2 into a, because this is the equation here. So when this is m2, so this equation 2 is been written as m2 into a, right? And this is equated here. This will come here, it is m2 into a. When this is come here, when this goes to the other side, it is m1 into a plus m2 into a. So when acceleration is out there, so it will become m1 plus m2. So that will be this one. Now you can substitute all of them and get the acceleration done. Okay. So what you do is a you substitute and then you substitute everything and you will get this answer. Now look at this question. So after this one, they substituted all of them. m2 3 kg, mu k this one, m1 is 20, close the bracket, g is 10, m1 plus m2, you get this answer. And afterwards you can find out tension also. Tension, if you found out acceleration, put it in one of this one and you can get tension also. It will be easy for you. Alright, we'll go to the next question now. Let us read the next question. Question number 8. A block A of mass 4 kg is placed on another block B of mass 5 kg. So this is 4 kg and this is 5 kg. Block A is placed on the 5 kg block, right? Looks quite small and big. It does ratio wise, it doesn't look good, but it's okay. You can imagine it could be just a heavy metal and something. It is a wooden piece or something. Fine, okay. And the block B rests on the smooth horizontal plane. This is already on the horizontal plane here. For sliding the block A on B, a horizontal force of 12 newtons is required to be applied on it. This one, if you apply in 12 newtons on A, then this will start sliding. Maximum, if you put 12 newtons, then it will start sliding here. That means the frictional force between A and B, you can find out what is the frictional force. Alright, and you can find out what is the coefficient of friction also, because maximum is only this one given here. So M1 is equal to 4 kg, M2 is going to be equal to 5 kg. Alright, and then force on A is 12 newtons. This is maximum force. It is given as 12 newtons. That means it is still not moving. You give maximum 12 newtons, it will be on the verge of movement. That means that much is the frictional force. So maximum force A, then body just starts moving. Just starts moving means that means what is the frictional force should be there? If 12 Newton only it is there and then it is just starts moving means the frictional force also will be maximum frictional force is only 12 newtons. So maximum frictional force is equal to 12 newtons. If maximum frictional force is 12 newtons, now we can find out the value of mu. So F is going to be equal to mu into m1 into g. So this is 12 newtons is equal to mu into, this is 4 kg into 9.8 here. Okay, this is 9.8. So what is mu equal to? You can bring this one down. Upon 4 into 9.8, it is going to be equal to 3 by 9.8. This is the value of mu. Now look at the next question, next part of the question here. How much maximum horizontal force can be applied on B, on this B down, B here? This force is going to be equal to question mark. This force is question mark here. Can be applied on B so that both A and B move together. Now you have to give a force such that A will not start sliding down. Sometimes now you give 200-300 newtons. What will happen when you just give a push on the B? Immediately A will start going in this direction and it will fall down. Have you seen that? When you pull this one very fast with a good force, then A will start moving down. They are saying you give a force, but don't give only that much. When A will be just on the verge of moving, it will not be anywhere able to go beyond that. If it is more force you give, then it will start moving and it will fall down. A and B should be together. So the force when you apply here on this body, now this is another frictional force will be here. Another frictional force will be there. And that frictional force, when it is there, it is a combination of both of the masses here. It will be together, which will be there. Alright. So that also we need to calculate here. And we need to see how much will be the value in which it is going to be here. So we will try to calculate here how much is the force which is going to be here. Right. So maximum force applied is going to be equal to the maximum force, whatever you apply, it should be equal to the frictional force here. Right? So how much it will be there? Alright, there is a one format of correction we need to have here. Let us read the question once again. Block A is of 4 kg present on the block B, and block B is 5 kg, and block B rests on the smooth horizontal table. What does it mean by smooth horizontal table? So block B is resting on a place where there is no friction. When there is no friction, you are now quite free to find out how much force it should be applied here so that A and B will be together and there is no frictional force here. Now we need to just make a final conclusion how much this force will be there on this one and how much this will give another frictional force on this one. We need to calculate, and then that will be the value. So you can write down the maximum force applied will be equal to addition of frictional force of A on B plus frictional force of B on A. So A on B and B on A, right? Because this is giving a reaction also. So this is giving an action and this is giving a reaction also. So we need to take that both of them together. So it's going to be equal to mu into m1 into g plus mu into m2 into g. What is m1 into g? It is the frictional force of A on B. What is mu into m2 into g? The normal reaction which comes here. This one, it gives another force. So that's going to be m2 into g. So it's going to be mu and g outside, m1 plus m2. So mu already we know this value. It is going to be 3 upon 9.8 into 9.8 into 4 plus 5. 9.8 it gets cancelled out. So 3 into 9, it is going to be equal to 27 newtons. That will be the force. That will be the force. Maximum you can apply. Maximum force you can apply is only that much. because A is giving a frictional force, B is already giving a frictional force to this one. So both the friction forces being added here, you will get 27 newtons. Right? And how much is the acceleration? You can find out the acceleration also. Now look at this one. The question is, we got 27 newtons is the answer here, and then there is the acceleration which is going to be here. Okay. So we'll do one more question, and with that we will close for today. So read this question. Question number 7. An aeroplane of 10,000 kg requires a speed of 20 meter per second square to take off the runway on a ground being 100 meters. So from rest, it has to travel 100 meters and then it will take off. Now 10,000 is the speed, this one, and then speed is, the maximum speed is 20 meter per second. Then it will be, final velocity is going to be this much. Initial velocity is 0, final velocity is this much, and this is the mass. The coefficient of friction between the wheels of the plane and the ground is 0.3. Assuming the plane accelerates uniformly during the takeoff, determine the maximum frictional force required from the engine of the plane to take off. Okay, so what is the maximum frictional force required by the engine of the plane to take off? So that's what it is asked. So write down the parameters now. What are the parameters you need to write here? First one is mass of the plane. So mass of the plane is 10,000 kilograms. And final velocity is 20 meter per second. Initial velocity is 0. And then distance is going to be equal to 100 meters. Alright. Now we can, using this one, you can find out the acceleration now. Now there is nothing beyond it is given here. So v square minus u square is equal to 2as. So it is 20 square minus 0 is equal to 2 into acceleration, you will find out, into 100. So it is 400 upon 200 is equal to a. So a is equal to 2 meter per second square. That is the acceleration in which the aeroplane, this entire aeroplane, will be doing. This one is, the entire aeroplane will be exerting is going in an acceleration of a is equal to 2 meter per second square. Now if this is the one, now the force is m into g and it has normal reaction capital R. How much is the mass? This is the mass here. So what we need to find out is, the next value is the force required for producing acceleration. How much is the force? The force, external force producing, is going to be equal to m into a. It is going to be equal to 10,000 into 2. It is equal to 20,000 newtons is needed. Now what is asked? Determine the minimum force required by the engine of the plane to take off. How much is the minimum force? So this is the maximum force is required here. Now is it only this much? Now you cannot take only this much the force. Now there is a frictional force also added here. So whenever it moves, the frictional force will be subtracted from here. If it has to go through this much of acceleration, you need to have a force this much. Alright. Now remember, only this much force, if it is there, still it will not take off, because some portion of this much will be subtracted because of the frictional force. So what we should do now? Add the frictional force also here. That much is the minimum force required to take off. I am again repeating. The minimum acceleration needed is 2 meter per second square. And it will be going on a velocity of 20 meter per second to take off. If it is 20 meters per second, it will take off. If it is 20 meter per second, acceleration is how much? 2 meter per second square. Now if 2 meter per second square is acceleration, how much is the external force is required? It is 20 newtons, 20,000 newtons will be the external force. Now if you give this much, will the plane take off? I will say no, it will not take off, because the frictional force will all oppose the wheels and it will stop the plane. It will not be able to go, because 20,000 minus frictional force will be there too. And you have reduced the maximum force whatever you are giving. So what we should do is, in order to the safety precaution, determine the minimum force required, add the frictional force also here. Minimum force needed is equal to external force plus frictional force. 20,000 plus mu into m into g. 20,000 plus, what is the mu value? Mu value is 0.3 into 10,000 into 9.8. So what is the value you will get here? The value you will get here is, this is 2 into 10 to the power of 4 plus, and what is the value? G is 10 they have asked, 10 here given, so it is good, 10. This is also 3 into 10 to the power of 4, so it's going to be equal to 5 into 10 to the power of 4 newtons. So friction 20,000, sorry, force is 20,000 plus friction is another 30,000, put together, then only it will take off. So that's a wonderful question, nice question to see that. So you have 5 into 10 to the power of 4 newtons. So concepts are quite difficult. Whenever you have friction, the questions will become quite tough. Please go through this question again. It's all answered here. 7, 8, 9, 10, 11, 12 we have done. So you will be doing a homework. The homework will be from the back of the exercise. Try this numericals here. The numericals is from page number 288. Page number 288. The numericals based on these questions: friction, coefficient of friction, and rough level surface. Question number 1, question number 2. There are 6 questions there. Please try these questions over the weekend. You should be able to do it. Right? Question number 3, 4, 5 and 6. Please try these questions. It will be very, very handy and helpful for you. Alright children, thank you so much. If you have any doubts, please get back to me in a WhatsApp number. Then we will be able to solve it. Thank you.